Let's now carefully look at how to detect air leaks in a home and talk about air barriers. Air leakage can occur just about anywhere within a home. You should be able to find those major air leak points during your inspection. The property owner probably already has an idea of some areas where leakage is occurring. For example, around some windows or an area under the door. But you need to find the less obvious gaps for the homeowner to properly get the home sealed up properly. A blower door test, which depressurizes a home, can reveal the location of many leaks. A complete energy audit will also help determine areas in the home that need more insulation. Without a blower door test, there are other ways to find some of the air leaks. First, look at the areas where different materials meet, such as between brick and wood siding, between the foundation walls, and between the siding and the chimney. Also inspect around the following areas for any cracks and gaps that could cause air leaks. The following areas also include parts of a house that would allow infiltration as well as exfiltration. Electrical and gas service entrances, mail chutes at the exterior door, window and door frames, cable TV and phone lines, recessed light fixtures, chimney chases, the refrigerant lines from outside condensing units, at intersections between different exterior siding materials, exterior windows and doors of the basement, sill plates, rim joists, the dryer vent, any plumbing penetrations, plumbing chases, the top plate at a partition wall, the entrance to an attic space, around interior trim, any of the registers of the furnace, holes in plaster or drywall areas, built-in dressers, cabinets, and shelving, anywhere around laundry chutes and floorboards, knee wall and framing intersections. Also air leakage points between the crawl space and condition spaces, around dormers and additions, overhangs, electrical wall receptacles and outlets, porch and house framing intersections, just to name a few. For those of you that haven't quite made the investment into a blower door, there's still some valuable information and steps that you can take to depressurize the home and help those leaks stand out. Number 1, turn off the furnace. Ideally, the weather would be cool and windy out. Number 2, shut all windows and doors. Turn on all exhaust fans that blow air outside, such as bathroom fans and stove vents. And light an incense stick and pass it around the edges of common leak sites. Whenever the smoke wavers or is sucked out of or blown into the room, there's a draft. If the furnace can't be shut off for whatever reason, you can just turn on all the exhaust fans to help depressurize the home. Other air leak detection methods include shining a flashlight at night over potential gaps while a partner observes the house from the outside. Large cracks will show up as rays of light. This really isn't the best way to detect small leaks, however. Also, shutting a door or window on a piece of paper. If you can pull the paper out without tearing it, there's likely some energy loss there. The door should be tight. Next, we talk about air barriers. Air barriers can help block air leaks. Reducing air leakage through the building envelope is a good practice, regardless of where air leaks are occurring. Air barrier systems are used to block air leaks at certain points in the building assembly while also addressing other envelope concerns with other methods, such as rainwater protection and vapor diffusion retarders, also known as VDRs. Appropriate air barrier materials include some panel products, membranes, and other coatings that have low air permeability. Examples of air barriers include spray polyurethane foams, gypsum wallboard, building wraps, poly foam boards, and exterior wood structural panels or sheathing. Seams and laps in these products must be sealed. Examples of products that might be considered too air permeable to serve as an air barrier includes fiberboard, expanded poly insulation, glass fiber insulation, and tarred felt paper. Ridge materials such as drywall, gypsum wallboard, exterior wood sheathing, and rigid foam boards are effective air barriers because they have the ability to resist differences in air pressure. There are 4 general methods to provide an effective home air barrier system. 2 of these approaches place the air barrier on the inside of the thermal envelope, and 2 place the barrier on the exterior of it. First, we look at the interior air barrier methods. We have the airtight drywall approach and the airtight polyethylene approach. The exterior air barrier methods are the airtight sheathing approach and the airtight wrap approach. If you're in a cold or especially cold climate, moisture tends to go from the interior conditioned spaces to the exterior through the wall and ceiling assemblies. The primary concern is preventing interior warm and humid air from flowing outward into a building's exterior envelope assembly in winter months. Such airflow can carry a large amount of moisture and cause condensation in the wall. Therefore, the use of an interior air barrier system in cold and very cold climates is preferred and may be combined with a warm and winter vapor diffusion retarder. A viable approach in such areas is the airtight drywall approach, used in conjunction with an interior vapor diffusion retarder layer, such as Craft Fast Bats or VDRs, vapor diffusion retarder paint on drywall. Use of airtight poly methods should be applied more cautiously, as some experts have concern that the poly layer is almost too airtight and vapor impermeable, and will not allow drying to the interior of the building at any time of the year. Conditioned interior spaces should be maintained at low moisture levels. In hot, humid climates, moisture tends to go from the exterior to the cooled interior by passing through the walls and ceilings. Our primary concern here is preventing exterior warm, humid air from leaking inward through the exterior surfaces into the building's envelope assembly that will then cool from air conditioning. In moist and humid climates, an air barrier system is preferred on the outside of the wall. Many exterior sheathing products, and wraps for that matter, can provide this function and also serves the water barrier function underneath any siding materials in place. Therefore, air sealing is important because air carries both moisture and energy, usually in the direction that's adverse to your client's wallet and comfort level. So let's look at air sealing. Air leaks can carry warm, moist air from a bathroom into a cool attic in the wintertime. Your client will probably already know that air can leak in and out of the house, through small openings and around doors and windows, or even through a fireplace chimney. Air can leak into the house from unconditioned spaces such as an attic, crawl space, or basement. What your client might not be fully aware of is that there's other pathways for air leakage, which include plumbing and electrical wire penetrations, openings or cracks where the wall meets the ceiling, any openings or cracks near interior door frames, any openings or cracks where 2 walls meet, gaps that are behind recessed cabinets, or around electrical outlets, recessed lights and switches, false ceilings or soffits in the kitchen, behind bathtubs and shower stall units, and through floor cavities of finished attics that are adjacent to unconditioned attic spaces. Air sealing is an essential first step. It is important to stop the air leakage prior to adding insulation in specific areas because the insulation might make pathways hidden and therefore difficult to access. Because warm air rises and cool air falls, the attic is often the best place to find air leaks and then seal them up. Usually, adding additional insulation at the attic's floor area will not stop leaks because the air will flow through or around the insulation. most insulation will not stop air leaks. Air leakage through building assemblies can move a large quantity of water vapor and is a major factor in many vapor-related moisture problems. Building envelopes should be designed and constructed to reduce air leakage from inside to outside in cold climates and from outside to inside in hot and humid climates. In order to achieve this objective, the big air leaks in the building's envelope must be sealed. Most insulation will not stop air leaks. In addition, a suitable air barrier system should be carefully considered and put into place during the construction of the home. Any one factor or a combination of the following factors can drive air leakage: wind, forced air HVAC equipment such as a central air handler, and the stack effect. Wind and stack effect driven air leakage are best handled by the use of air barriers. HVAC equipment should be properly installed, and seams and connections in the distribution piping should be sealed airtight. There's some precautions worth mentioning if the building envelope is too tight. First, the use of air barriers and air leakage sealing practices can reduce the supply of combustion air for fuel-fired equipment. For example, gas or oil furnaces, maybe a gas water heater or dryer. If these are located within the conditioned space, this might be a concern. This can also result in negative pressure and backdrafting of combustion products. The operation of spot exhaust fans, such as those in the kitchen and bathroom, whole house exhaust ventilation systems, or even the stack effect, can also cause depressurization of the indoor space near combustion equipment, which can lead to backdrafting and the introduction of combustion byproducts, such as carbon monoxide, into the home. Because of these health and safety concerns, sealed combustion equipment is often installed when the house is tight. Second, mechanical ventilation may be required or recommended to address other consequences of tightening the building envelope, such as indoor air quality and humidity control. For example, modern building practices still permit the use of operable fans as a means of providing fresh air ventilation, though this has been contested in recent years. It may be risky to rely solely on the behavior of the occupant to provide adequate ventilation in this manner in the absence of higher levels of natural ventilation. Therefore, as a final precaution, air barrier materials must also be considered in terms of their impact on vapor movement as well as water shedding. For example, if an air barrier is used on the exterior of the wall as a weather barrier underneath cladding, it must also have adequate water-resistant qualities. And if an air barrier is used on the inside of a wall in a hot or humid climate, it needs to be permeable material and not one that will prevent vapor from drying to the inside. We want to ensure that the air barrier functions as intended, that leaks in the building envelope and the air barrier system are reasonably controlled. The methods are generally low-tech and really make common sense. Building codes require air sealing around the following types of areas: knee walls, openings between window and door assemblies, as well as their respective jambs and framing, all joints, seams, and penetrations, including utility penetrations, site-built windows, doors, as well as skylights, openings behind tub and shower enclosures on exterior walls, common walls between dwelling units, walls that separate ceilings from an attached garage of a conditioned space, and any other sources of air leakage. Sealing materials include acceptable air barrier materials and durable caulks, weather stripping, tapes, and gaskets, as well as sealants as appropriate. The air barrier material could be a suitable film or a solid material. It's usually most practical to focus on the big leaks that have the big holes, but all obvious air leakage pathways should be sealed. Some of the major leakage points that should be air sealed include plumbing stack penetrations, floor overhangs, openings behind tub and shower enclosures, attic access hatches, as well as pull-down stairs, vertical mechanical chases, utility penetrations in walls, and any exposed wall cavities that might open up to an adjacent attic space. It's important to seal up any leakage pathways between the living space as well as the attic space, especially before your client adds any insulation in the attic. The materials for sealing air leakage pathways should include products that are durable and compatible with the join materials, especially around hot surfaces. Some of these examples include spray polyurethane foam, construction adhesives, gaskets, sill sealers, high-quality caulks, tapes, as well as a number of specialty products such as gasketed electrical receptacles, switches, and ceiling light fixtures. There's some special considerations when dealing with cathedral roofs as well as air leaks. Cathedral roofs can hide roof water leaks as well as condensation, particularly if a vapor diffusion retarder, such as poly sheeting, is used on the ceiling side, something that should be considered only in very cold climates. If there are cathedral ceilings in the house, the ceiling and penetrations through the ceiling should be carefully sealed to prevent any air leakage. This may also include special air-sealed light fixtures, as well as caulks and sealants at all penetrations and joints, and avoiding leaky ceiling systems such as exposed tongue and groove boards. Leakage of humid indoor air into cold cathedral roof cavities is a major cause of condensation and moisture problems in these kinds of roofs. For cathedral ceilings, there needs to be enough space between the roof deck and the ceiling for adequate insulation and ventilation. Adequate insulation thickness can be achieved when the builder uses raised trusses, truss joists, scissor truss framing, or sufficiently large rafters. You should know that cathedral ceilings that have a 2x12 rafter board has a maximum amount of space only for 10-inch thick R30 batt insulation. You may see foil-faced batt insulation used in a cathedral ceiling because it has a 0.5 perm rating and provides the permeability often required for use in ceilings without attic spaces. You should see vent baffle installed between the insulation and the roof decking to make sure that proper ventilation is maintained. If the roof framing at the cathedral ceiling cannot provide enough room for proper insulation and ventilation, then you might see furring strips attached to the underside of the rafter boards. These furring strips will provide enough room for thicker insulation to be installed. Some builders will install high-density batts in tight areas or add rigid foam insulation under the rafters. Rigid foam insulation is a good choice because of its ability to resist thermal bridging through the rafters. As a reminder, airflow can transfer significant moisture vapor through and into the building assemblies. The amounts can be 10 to 100 times more than what would typically occur by vapor diffusion. Significant air leaks from a bathroom into a cold attic, for example, can deposit large amounts of moisture vapor on cool surfaces and then create condensation and water accumulation damage. This water will also make some insulation materials ineffective. Without reasonable air leakage control, the use of vapor diffusion retarders is of limited benefit. Similarly, attempts to pressurize a building in a hot, humid climate to control against the intrusion of outdoor humidity or to depressurize a building in a cold climate are far more effective with a tighter building shell. Some amount of natural air leakage under the right climate conditions can be a good thing. Old houses naturally breathe. Under ideal conditions that may occur during some months of the year, it can help to dry the house. Air leakage in the form of intended ventilation in attics, as well as crawl spaces, is a good way to reduce moisture and very effective in many climates. Air leakage that occurs through the thermal envelope can also allow for uncontrolled natural ventilation of the building for indoor air quality. However, the benefits of air infiltration through a building's thermal envelope are either unreliable or risky in many climates. Therefore, dependence on excessive or uncontrolled air leakage through modern building thermal envelope systems is generally discouraged. And in fact, modern building standards and energy codes usually require fairly extensive practices to prevent the uncontrolled leakage of air through a building's thermal envelope.